So let's finish strong here, and let's talk a little bit about parametric equations. Okay? So we are in the brown packet that some of you got before break, some of you just picked up today, some of you at home might have printed it off. Okay, we're in that brown packet, page number 1. Okay? So page 1 says, if we were a regular old function, so we're a regular old function, and we would be putting x values into that function. So for instance, if we were like y equals 3x plus 2. Okay? So that's what we are. Y equals 3x plus 2. We take an x value, we put it into that function, we get out a y value. Right? Okay? So x is our independent variable. Y is our dependent variable. Dependent variable. Right? And we plot, if we were graphing these, we plot the points x, comma, y, right? That's what we would use to put on our graph, and we do that. Or, really, what we're plotting is x, comma, f of x, right? Because we take x values, we pick these, we plug in, and we get those. Right? That's how a regular old function would work. Okay? Love. Great. All is well. Except now, we go and we, just when you have all of the answers, I go and I change the question. Okay? So now what we're going to do is now we're going to work with parametric equations. Parametric equations have 3 variables. Okay? The third variable, t, is called the parameter. Okay? It is now your input. So t is your independent variable. Both x and y are going to be defined by a function of t. So instead of just having like y equals 3x plus 2, now what you're going to have is you're going to have something like x equals 3t plus 1, and y is going to equal t squared minus 2, or something like that. Okay? That's what your parametric equation is going to look like now. X is going to be a function of t. Y is going to be a function of t. So what you have to do is now, you, instead of making a regular old t chart, I don't even know what kind of funky letter this is, let's call it a pie chart. So now you're going to have t, x, and y because you have 3 variables. So now you're going to pick these, you're going to plug into the x function, to get these, and you're going to plug into the y function. To get those. So both x and y are your dependent variables now. Both x and y are dependent. Now, when we go to plot these, we are still, because we're going to be graphing these today, we still plot x comma y. But now, x is really f of t, and y is really g of t, because of these. They're going to be defined functions. You have been working with a parametric function since October. You just didn't know that it was a parametric function. The unit circle is parametric. The unit circle is parametric. So my x function, what are the x values of all of the points on the unit circle? X values, all points, unit circle. So x is the cosine of theta, right? Or in this case, it would be the cosine of t. What's y? It'd be sine of t. Yeah. And t, the values of t that we put in, that's our angle measures, right? That's theta. So for any angle, if you put that angle into cosine, you get the x value. We did the sweet 16 on the unit circle. So if my angle is 2 pi over 3, I put 2 pi over 3 into x, I get out negative 1/2. I put 2 pi over 3 into y, I get root 3 over 2. And that point is on the unit circle. Okay? So the unit circle is a big time parametric equation, or parametric function, if you will. Okay? All right? So let's dive into number 1 now on the TAN packet. We're going to graph these functions. Okay? We're going to graph them 3 ways. We're going to graph them by hand, we're going to graph them with a calculator, and we're going to graph them with decimals. Okay? And I'm going to show you how to do each of those, and then you can determine which one you like the best. Okay? So if we are graphing this function, so we've got our x function of t squared minus 9. We've got our y function of t, 2t plus 1. And then we've got t is negative 3 to 2. And this tells me the range of t values. Now, in the past, when we've graphed something, okay, so I'm just going to throw a regular old graph on there. In the past, we've graphed something. Don't write this down because we're going to actually put something on this graph. We've put arrowheads on the end. And those arrowheads have signified that that graph is going to continue on in that pattern forever and ever and ever and ever. Okay? What t, limiting your value of t, does is we are just taking a section of that graph. And that's it. These parametrics that we are graphing have, oops, I guess I erased my t value here. These graphs are just sections. They don't go on forever in both directions. We're just taking a little piece of it and graphing that. Okay? So let's do this. So by hand, what we're going to do is we are going to make our funky t-chart, and our t values are going to be -3, -2, -1, 0, 1, and 2, because I need to start at -3 and I need to stop at +2. Okay? Now, what we do is we take, and I'll do this one time, and then after that we'll just do it in our head because we're that smart. Okay? So in our brains, what we're doing is we're taking our x function here is t squared minus 9. So I'm going to take -3, I'm going to square it, and I'm going to subtract 9 from it. Well, -3 squared is 9, minus 9 is 0. So the x value here is 0. Then I'm going to take -3 and I'm going to put it into 2t minus 1, plus 1. And I'm going to say 2 times -3 is -6 plus 1 is -5. So the point that this one makes is 0, -5. With me? Speak now or forever hold your peace. That goes for you people at the home too. Okay? Speak now or forever hold your peace. Okay? Then, now you could, on your t-chart, you can do any value as long as that value is between -3 and +2. I chose the whole numbers, the integers, if you will, because they're, but if you wanted to get all rows and do like -2.75, you go. You do you, I'm going to do me. Okay? So -2 squared. What is -2 squared? 4. 4 minus 9. -5. So that value there is -5. -2 times 2. -4 plus 1. -3. So this one gives me the point -5, -3. With me? Okay? -1 squared. 1 minus 9. -8. -1 times 2. -2 plus 1. -1. So that gives me the point -8, -1. Love it. Okay. Again, I'm not going to ask you questions that I know you. How do I want to say it? I'm not going to ask you questions you can't answer. Okay. All right. So let's participate a little bit. 0 squared. 0 minus 9. -9. 0 times 2. Plus 1. 1. So that gives me the point negative 9, comma 1. 1 times, or excuse me, 1 squared. 1 minus 9, negative 8. 1 times 2, plus 1, 3. 2 squared, minus 9, negative 5. 2 times 2, plus 1. So that gives me the point negative 5, comma 5. Yes? Love it. So now let's plot those points on our graph. Okay? Well, the point 0, comma negative 5 is 1, 2, 3, 4, and 5. Right there. The point negative 5, comma negative 3, 1, 2, 3, 4, 5, 1, 2, and 3 is right there. The point negative 8, comma negative 1, 5, 6, 7, 8, negative 1. Negative 9, positive 1. Negative 8, positive 3. Negative 5, positive 5. So we got that. Those are our points. Now we're going to connect those dots. La, 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 la. But we're not going to go any further than those dots. That's it. We're just taking that slice of the graph. Drink some. Mountain Dew. It'll get you awake. Oh. Okay? Okay? That's it. Don't put arrowheads on it because they don't belong. Okay? Okay? They don't belong. It's like me going into a fancy restaurant. It just doesn't belong. Okay? You weren't supposed to agree so vehemently with that. Okay? Okay? Now, the other part of this question is it's asking you to eliminate the parameter, okay? Or eliminate t. And there's 3 quick and easy steps to do that. First off, you're going to solve x or y, it doesn't matter which one, for t. Okay? So looking at the parametric equation, x equals t squared minus 9, y equals 2t plus 1. Which one do you think is going to be easier to solve for t? X or y? The y is, I think, is also going to be easier to solve for t. So y equals 2t plus 1. If I want to solve that for t, what do I have to do? Okay, how? First, subtract the 1. Love it. Gives me y minus 1 equals 2t. Then, divide both sides by 2. That's going to give me y minus 1 over 2 is equal to t, or t is equal to 1/2 times the quantity y minus 1. Either one of those works. Right? Okay. That's step number 1. Step number 2 says we are going to plug that into the other. So we're going to substitute for t. Okay? And then what we're going to do is we're going to simplify. So my other equation was x equals t squared minus 9. So if I plug that in, I get x equals 1/2 quantity y minus 1 squared minus 9. When I plug that in. Right? And if I simplify that, that simply is x equals 1/4, because if I'm squaring a times b, that's a squared b squared. So 1/2 squared is 1/4. Times the quantity y minus 1 squared minus 9. Okay. Now, we skipped over conic sections in first semester. Okay. Had we not done that, what this is this is a parabola, because one variable is squared, so that makes it a parabola, but it's a parabola that opens to the right. Okay? It's a right opening parabola, which, if you look at our graph, if we would continue this out a little bit here, there is our parabola that opens to the right. And we're just taking a section of it. Okay? Love it. If you turn your page over to page 2, you will find example 2. Okay? What I would like you to do on example 2 is I would like you to graph it by hand, and I would like you to make the table, and I would like you to eliminate the parameter. So we want you to eliminate t at this time. When you're done with that, then we will verify it using a graphing calculator. Then we'll verify it using decimals. Okay? Not a dodecagon, just so you know. Okay? So we make our chart. We throw a little t values in there. We started at -2, then we went to -1, 0, 1, 2, and we're stopping at 3. The only two that really matter are the first one and the last one. Are the only ones that really, truly matter in that. Okay? So again, x was t plus 1. So that's going to be -1, 0, 1, 2, 3, and 4. Okay? Y was t squared plus 2t. -2 squared is 4. 2 times -2 is -4. 4 plus -4 is 0. -1 squared is 1. -2 is -1. 0 squared plus 0 is 0. 1 squared is 1 plus 2 is 3. 2 squared is 4 plus 4 is 8. 3 squared is 9 plus 6 is 15. Okay? So plotting those points, so -1, 0 is right there. 0, -1 is right there. 1, 0 is right there. 2, 3 is there. 3, 8. 4, 5, 6, 7, 8. 4, 15 right there. Drawing in my graph. And I stop at both ends. Questions, comments, concerns, clarifications? Yes? Thumbs up on all of that? Yes? Yeah? Good? All right. Let's eliminate the parameter then. First step, I need to pick one of them, and I need to solve it for t. I am going to pick x equals t plus 1. And if I solve that for t, I get x minus 1 is equal to t. Need to plug that into my y equation now. Y is going to equal that. I can make that look nicer. This could be x squared minus 2x plus 1 plus 2x minus 2. So we could make y here be x squared minus 1. Would make it look nice. Okay? Y equals x squared minus 1 as a function is an upwards opening parabola shifted down 1. Well, if we go back and we look at our graph, we've got what appears to be an upwards opening parabola shifted down 1. Okay, we just have a chunk of it. Took a chunk out. Okay. Questions on that? I want everybody to be done with that before we start the next part. It said to verify it on the calculator. So all of you have an Inspire calculator there at your desk. What I would like you to do now is I would like you to double tap the on button. Okay? So when you double tap the on button, the first one turns it on. The second one gets you to a screen that looks like this. I am a very big proponent of documents. So I want you to all start a new document. And it's going to ask you if you wanted to save the old one, and no, we don't want to save that. Okay? So we don't want to save that old document. We just want to start a brand new one. So here's our new screen. We want to graph this parametric equation, so we are going to add a graph. Everybody with me so far? Okay. When we go to add the graph then, it's in function mode. So you can only input like y equals 3x plus 2. Okay? You could enter that, it would graph the line, all that fun stuff. We need to change that entry mode. So we're going to go to menu. The logical choice would be graph entry and edit. That's the one that we want to pick. And that now gives us all the different choices that we have for entering. We're going to pick parametric equations because that's what we're dealing with. So menu, entry, edit, parametric. Okay? And now what it's done is it set up the parametric equation for us to enter. Okay? So our x value was t plus 1. And then if I hit tab, it takes me down to the y. The y was t squared plus 2t. Then if I hit tab again, it takes me to this line. Well, on this line, I really just want to adjust my t value. So I'm going to scroll over to the 0, and I'm going to make that 0 become negative 2. Now, I will tell you that this is the negative button, not the subtraction button. You'll get a fancy error message if you use the subtraction button. Okay? And then I'm going to go over to 6.28. Oops. Escape. And I'm going to delete 6.28, and I'm going to put in 3. So we're there.
Do we change the t-step at all?
Well, what is the t-step? Do you know? The t-step is how often you're having the calculator calculate the values of this equation. Okay? When we were doing it back, I gotta go back up here now. When we were doing it here, our t-step was 1, because we were only calculating it every one time. But your calculator is much more sophisticated and can do things much more quickly, so we'll leave that at 0.13. Okay? The smaller that value is, the smoother your curve is. The larger that value is, the more chunkier it gets. Okay? And when you hit enter, shabam, there it is. But we went up to 15, correct? Because we have that t-chart value. Okay? So we're going to go menu, window zoom, and we're going to edit our window settings. X's we're fine with. Oops, I went too far. Y minimum, we're going to make that just be -5. Y maximum, we're going to make that be 20. And I like going by ones. And there is our and if I were to capture the page, and those two look very simple. Love it. Now, let's do the same thing. We're going to end up with the same graph, but now let's do it on Desmos. So now what I need you to do is now I'm going to need you to open up yourself a browser tab, and those of you at home can also follow along now on your browser tab. Desmos.com. Okay. We're going to use the graphing calculator on Desmos.com here now. Okay. Now, Desmos.com is kind of cool. Okay. So it's a graphing calculator. I can type in like y equals 3x plus 2, and it'll graph it for me. Okay. I can type in like an ordered pair 3, 2, and it'll graph it for me. Okay? Right? But there's no real way to do a parametric equation. But luckily, those designers at the Desmos were smart, and they said, well, a parametric equation is kind of like an ordered pair. Okay? So if we can graph an ordered pair, we can graph a parametric. So the x value was t plus 1. So I'm going to put that in my ordered pair as the x part. Then I'm going to put the t squared plus 2t in the other part. But how do I do the squared? Well, you go down here to this little like show keypad thing. And in it has all of these wonderful functions. Squared, absolute value, square root, some other power. Your trig functions are over here. All that fun stuff. And so we want t squared, then plus 2t. And then you can get rid of that so you can see more like that. Okay? And now Desmos says, tap the brakes. They're doing a parametric equation. Let's set those t values. So if we tab over there, or if you just hover over there, oops, maybe not, maybe you gotta tab twice. There you go. If you tab over there, we want to go from -2 to +3. And there it is. Okay. Now again, can't see the whole graph because we go up to 15 and we only went up to 6. So over here, so we got two options. One, you could click and drag, but then that gets kind of messy and your numbers get all kinds of weirdness. Okay? But you can also go over here and you can say, okay, here's my x-axis, here's my y-axis. Well, I want to go here with -5. And I want to go here with 20. And now what it's done is, and then when you click out of there, there is our graph. So now I got to go way back over here. And I got to go this one. And now it's going to get a little loud here. Ching. Send to the, hold on, tap the brakes. Yep, send to the current page in the smartboard. And there it is. Okay. Handle? Awesome. Love it. And we got the same graph going on. So what I would like you to do now is I would like you to, and I'll let you choose how you want to do it. If you want to do it by hand, if you want to do it by the graphing calculator, if you want to do it on Desmos, I want you to guess what that graph is, and then I want you to actually graph it. I'm going to use Desmos just because I want to show you a couple more things in Desmos. So x here is going to be defined as 6 cosine of t, right? And y is defined as 6 sine of t, right? And we wanted to go from 0 to 2 pi. Now, here's a cool thing that I just found out this morning about Desmos. I want to go to 2 pi, so I'm going to go 2, and then on my keyboard, I'm going to type in pi. And shabam, it puts pi in there for me. Huh? That's pretty cool. Again, I'm a numbers guy. I get jazzed up by cool stuff like this. So what do you think that looks like? It's tough to say, right? Because it goes out 6 to the left, it goes up 6 to the left, but this scale looks a little different, right? So one thing that you can do is you can go over here to the wrench and you can hit this zoom square. And what that zoom square does is it squares up your graph so that the spacing is the same both horizontally and vertically. And when you do that, it tightens everything up, and oh, look at that. What do we got? We got a circle centered at the origin with a radius of 6.